Hello, today we'll try to understand if the bases in an exponential function are same, then is it necessary for the exponents also to be the same? No, it is not always necessary for the exponents to be the same. I'll take an example and then show you the proof of it. So let us say I'm writing 1 raised to the power 5 is equal to 1 raised to the power 0. In both these conditions, we know that the result is 1, which means can we write 5 is equal to 0? Definitely not. 5 is not equal to 0. So we have seen through an example that when the bases are same in an exponential equation, it is not always necessary for the exponents also to be the same. So what we are going to do is today we'll try proving it. So to prove this, what first we are going to do is we are going to take what is given to us. So we have been given that x raised to the power a is equal to x to the exponent b. Now from here we can write it as x exponent a divided by x to the exponent b is equal to 1. So I just got this here into division. Now using the quotient rule of exponents, because the bases are the same, so the exponents will be subtracted, which means I can write it down as x raised to the power of a subtract b, and this is equal to 1. Now let me take log both sides. So if I take log both sides, we get log x raised to the exponent a minus b is equal to log 1. Now, using the logarithmic rule, what I can do is this comes in multiplication. So this can be written as a subtract b multiplied by log x is equal to 0, because we know that log 1 is equal to 0. Now here we have that the product of these two numbers is equal to 0, which means either of them have to be 0 for this equation to be true. So one condition is that a minus b could be 0. So we are saying if a minus b is equal to 0, then definitely we can have a equal to b. So yes, it could be same, but there's one more condition, that if log x is equal to 0, so if log x is 0, then it is not necessary for a minus b to be 0, which means if log x is equal to 0, then a minus b does not have to be 0, which means a does not have to be equal to b. So we have been able to prove that if x exponent a and x exponent b, if they are both equal, just because the bases are same, so it is not necessary that a will always be equal to b. And in this case, when does this happen? When is log x is equal to 0? When x is equal to 1. So when the base is 1, we would never be able to equate the exponents. That's one condition. Now there's one more thing, that because it is log, and for log of a number, we have a restriction. Our x cannot be 0 or negative. So our restriction is that x needs to be greater than 0, and hence this equation does not hold good when x is equal to 0, because we know that 0 raised to the power of 3 is 0. 0 raised to the power of 4 is also 0. But can we say that 3 is equal to 4? No, just because the bases are same, we cannot equate the exponents over here. So this does not hold when x is equal to 0. That's another condition. And because it has to be greater than 0, so if we take x is equal to -1, then also this equation does not hold true. We can clearly see it. So if we have -1 raised to the power of 3, and that's equal to -1 raised to the power of 5, because we know for both of them, the final outcome is going to be -1. Just because both are -1 and the bases are same, can we equate these exponents together? Definitely not. 3 is not equal to 5. So which means this equation does not hold true when x is equal to 1, when x is equal to 0, and when x is equal to -1. I hope you understood and enjoyed the video. See you in the next one. Bye-bye.